Welcome to our primary webinar for maths. My name's Elizabeth Ivory and I'm Head of Marketing and Communications at Folens. I hope you're not hearing that repeat sound I'm hearing, but I'll just be very quick before I hand over to Patrick Neary, who's an experienced author and teacher, and he's going to take us through preparing for the new maths curriculum, mathematical modelling. I'll give a very quick update from Folens, and then I'll be joined by Ciara Walsh and Patrick again for a Q&A session. So if you have any questions at all during the presentation, you can just pop them into the chat box on your screen, and then we'll get through as many of them at the end as possible. So without further ado, I'll hand over to Patrick.
Thanks a million, Elizabeth. I'll just get screen shared now. Now, hopefully, everyone can see that now, and we're all set to go. So, yeah, thanks a million, Elizabeth, for the introduction. It's lovely to be back here with Folens again, delivering another webinar on maths education. As Elizabeth said, my name is Patrick Neary, and I've been teaching now for 10 years. So I currently teach in St. Cronan's Senior National School in Swords, and I'm also one of the authors on my problem solving journal. I authored the 5th and 6th class books. As teachers, we've definitely been through an awful lot in the last 3 years. And I think everybody here deserves so much credit for taking time out of your busy evenings. And I really hope that you get something from today's session. Mathematical modelling is our focus today. And it's something that I've been interested in for quite some time, and I'm really happy to see it emphasised in the draft primary maths curriculum. It's great to see it getting a place of attention in the curriculum. So here this evening, I'm going to be speaking about my experiences as a teacher, and towards the end, I'll be discussing my problem-solving journal and how it integrates with the ideas of mathematical modelling. It goes without saying that, you know, I'm not here speaking on behalf of the NCCA or the PTSD, but rather sharing my interpretations of the draft curriculum and how it interacts with my teaching and the work I've done to date on mathematical modelling. So there's four sections to today's webinar. I'm going to start off by looking at the draft primary maths curriculum and how it's come into being, kind of what research has been there before the curriculum, what has led to it being written. Secondly, we're going to look at what exactly mathematical modelling is, and then we'll look at mathematical modelling in practice. So this is really what it looks like in my classroom, how I find using it and my experiences of it. And finally, we'll look at mathematical modelling within my problem-solving journal and look at how, as authors, we considered mathematical modelling as we were writing it and how we tried to create opportunities to promote modelling. So that's a brief outline. Roughly about 30 minutes I'll be chatting, and if you have any questions as we go through, as Elizabeth said, use the chat box. Pop them in and we'll get to as many of them as we can at the end. So first of all, looking at the draft primary maths curriculum, kind of an overview of it. So I want to begin by looking at where it came from. So there was the first research reports were published by the NCCA in 2014, and these are really detailed documents with a huge amount of research in them. Following on from that, a draft curriculum was prepared, drawing on all that research, and this curriculum focused on junior infants to 2nd class. And that was back in 2018. So some of you might have engaged in, looked at this or engaged with pilots with it and given consultation feedback on it. Following on from that, there was a research addendum in 2019 which brought those ideas from the junior end up to senior primary, and that was written by Dr. Trace Dooley from GCU. Subsequently, in 2021, there was 5 more research reports written, and these were written one for each strand, and again written by experts in the area of maths education. Finally, then in 2022, we got the draft primary curriculum, maths curriculum, and the draft toolkit as well. The reason I like to show this slide and mention all that's gone into creating this document is because it gives me great confidence in the draft curriculum. It shows all of the different people, all of the experts who were involved in writing the research, and that research informed the draft curriculum that we have today. And also shows how much time the NCCA have put into it, and all the expertise and thought that has gone into preparing this document. So it really gives me confidence that you know, it's worth investing in this curriculum. It's worth spending time looking at it and trying to make sense of it and incorporate the ideas into my teaching. So it's just you know, I think it's worthwhile looking back at where it came from. The draft curriculum itself is broken up into 3 sections. First of all, we have the rationale, aims, strands, and elements, and that's really the background, the curriculum, and the different elements of it. Then we have the learning outcomes. You'll be familiar with learning outcomes from our engagement with the primary language curriculum, and it's a similar structure for maths, that it'll be learning outcome based rather than overly specific objectives. And finally, the third section is the primary mathematics curriculum and practice. And that's really where today's webinar sits, in that third section. It's kind of the nuts and bolts of how do you teach maths using this new curriculum. If I was to focus on just one part of this curriculum, it would be that section that I would send you to. It is full of ideas that you're probably familiar with. You may not exactly, like, it's definitely things that you're already doing in your teaching. Whether or not you're using the terminology or not is kind of beside the point. Opportunity to look at how we're teaching, to reflect on what practices we're using, and to maybe refocus towards the practices that are in this section. And I guess those practices are backed up by the huge amount of research that we saw on the previous slide. So today's webinar will really zone in on that third section. That third section, the curriculum and practice, is broken down into 5 pedagogical practices. These are 5 subsections with 5 different elements of teaching maths. So we have using cognitively challenging tasks, promoting maths talk, fostering productive disposition, using formative assessment, and emphasizing mathematical modeling. Emphasizing mathematical modeling is the area that I have huge interest in. I've looked at it in detail, and the area that we'll focus on today. These 5 elements or 5 practices underpin and embody the new vision for children's learning. So it's that whole idea of the curriculum is both what we teach, but also how we teach it. And this is the section of the curriculum that will help us with the how do we teach it part. So the next thing we're going to look at is, what is mathematical modeling? So what's it all about? What does it look like? Kind of thinking as well about, in what ways am I already using mathematical modeling in my classroom? And maybe are there opportunities to use it to a greater extent in my classroom? So there's accompanying the curriculum, there's a number of support documents, and the support documents are very teacher friendly, and they offer more detail on lots of parts of the curriculum that the authors felt that teachers do with some extra support with. And in one of those documents, which is called an Introduction to Mathematical Modelling, it defines modelling as using mathematics to describe a problem context and to determine meaningful solutions to the problem. So there's a good bit in there that it's all about the children using maths themselves. And second thing, it needs to be a problem context. So there has to be a problem or a real life context involved. And the children are trying to determine meaningful solutions. So they're trying to make sense, they're trying to drive meaning, and it's all about building on their prior knowledge and making connections. It involves children communicating their ideas and their thinking, and is everything they record, everything like any diagrams they draw, any pictures they draw, symbols, written word, it could be spoken language even as they explain their thinking, and concrete materials. So it's quite broad. For me, there are three main types of, or three main elements to modelling. So we have models that teachers might use and introduce to reflect children's thinking. We have models that children generate to help them make sense of a new maths idea. And then we have models that children make and create to make sense of a more messy situation. I'm thinking there are things like STEM investigations and real life scenarios. So the first one, the models that reflect children's thinking. This is where the teacher might introduce a model and use it to describe what a child has said in response to a problem or in response to a scenario. So for example, with the 10 frame, a child might make some response to a real life scenario, and the teacher might use the 10 frame to model what they're thinking, to help explain what they're thinking to the rest of the class. And then hopefully through the use of this model with the teacher introducing it, that the children will then be able to use it to engage with problems as they move on. I think it's definitely fair to say that teachers across Ireland are great for introducing models, particularly at the junior end, and using concrete materials, using different representations to help make maths more meaningful for children. And with these models and with the things like Dean's blocks, 10 frames, empty number lines, we'd be encouraged to try and choose a small number of them as a school and to use them very regularly, to engage deeply with them rather than trying to use as many as possible, and then the meaning can get lost. The second type of model then is when children generate their own models to make sense of a new idea in maths. So this could be models that the children draw, it could be using concrete resources, or it might just be ways of doing maths. So this example that you can see on the screen is where a child came up with their own way of solving a typical question from a long division unit. So the question basically asked them to divide 216 by 18, but the children had never experienced division with large numbers before. So instead of showing the children a method to solve this problem, the children were asked to try and come up with a way to solve this context-based problem. And you can see an example on the screen where they divided by 6 first and then by 3. So it's drawing on their previous understandings of division, of maths, so like across the entire number strand, and trying to use what they know to solve a new or a tricky problem. The third type of, for me, the third type of mathematical modelling is when they're trying to make sense of a situation. So this might be something that's more STEM based, or it's less about learning something new in number and more about making sense of the world around us. And so this problem from my problem solving journal was all about how many cans of tomatoes would fit in a box. And the children were trying to model the real life situation using pictures, they were using number, they were using measurements. So they were drawing on loads of different thinking from across the maths curriculum and their own experiences, and trying to put that together to figure out a solution to the problem. So there's three distinct parts there that all lend themselves to mathematical modelling. For me, and in the next section, we're going to focus on the one in the middle, where children are modelling, using mathematical modelling to make sense of new maths ideas. Today, or in this week with sixth class, we were looking at fractions, decimals and percentages, and it kind of seemed relevant to this whole idea of mathematical modelling. And one of the questions that came up was, what is 60% of 480? And it's a question that when I first started teaching, I would have had one really specific way of teaching this, that I felt that there was one right way to do it, and they all needed to do it the way that I was suggesting. Just out of curiosity, in the chat box, if you could add a comment just saying, how would you do this? How would you get 60% of 480? It would just be interesting, even for to have a look through the responses yourselves and see the different ways that you, even as teachers, would approach this question. When we were doing it today, there was at least 6 or 7 different ways that children were using around the classroom. You know, some children would get 10% of 480 because they know that instantly, and then multiply 48 by 6. Some people would have done kind of completed the same steps, but when they saw 60%, they were thinking 60% is 6/10, so we'll divide by 10 and then we'll multiply by 6. Others saw 60% and said that's 3/5 and divided by 5 multiplied by 3. One boy saw 60% and he knew that that was 0.6, and then on his calculator he was multiplying 480 times 0.6. So there's so many different ways that children can engage with a simple question like, what is 60% of 480? And instead of asking them to do, oh, I don't know, 10 questions with what is 10% of 240, what is 20% of 360, instead of asking them to do the same type of question over and over again and do each one in the same way, if we try and slow it down a bit and take one question and ask maybe, what is 60% of 480 and how many different ways can you come up with the answer? Then we're encouraging them to model their mathematical thinking, to find different ways of looking at the same thing and to find ways of recording that in their copies. So it's not that really the questions change or the content that we present changes. It's more the questions that we ask with it. So instead of focusing maybe on what answer did you get, to focus more on how did you do it. So if you have a minute to stick, you can type into the chat box, just out of interest, how would you approach this question? It would just be interesting to see each other's responses. So the next thing we're going to look at is mathematical modelling in practice. And here I'm thinking, so mathematical modelling is something that it's not really a standalone lesson or just you know, one thing that you do once a week. It's more really an approach to teaching maths. And this is looking at a unit of work that was taught over the course of about 2 weeks. This example, it's from a research project that I conducted with Dr. Shuan McVurry. She's works on Maths for All, and she's a lecturer in maths education in DCU. And it focused on teaching division to 5th class, traditionally, I guess, what we'd call long division. And it was the first time that they looked at it. This approach is something that I've used a good few times with different classes. And I find it works really well for me and in my classroom, but I'm very aware that different people will have different opinions on it. And that's perfectly okay. Like the reason I'm here this evening, I guess, is to start a conversation, and I'm as interested in those of you who disagree with me as those of you who do. I guess the first time I would have experienced mathematical modeling was when I was doing my master's in DCU, and the way we kind of came to our own understandings of it was through debate, through disagreements, different opinions. And I think that's the healthiest way to approach a new curriculum and to approach what we think is the best way to teach maths. Like, you are all the experts. You're the ones out teaching maths every day to the children in front of you. So I'm not here saying this is, you all have to change and do things this way. But I do hope that, it might maybe spark a conversation or a debate with your colleagues, or just to think about this way of teaching a new topic. So there's kind of a way of using this approach that focuses on the children generating their own informal models. And the most important thing to start off with is that it's context specific. So it has to be something that they can imagine, something that they can maybe represent with resources, or something that they can actually visualize happening that makes sense to them. The second thing is that models evolve as the children test, revise, and express their ideas. So whatever way the children start working, we're hoping that that's going to develop and that's going to change over the course of the series of lessons. We hope then that as their experiences grow, that the models become more sophisticated and more efficient. And towards the end of the unit, I would introduce kind of the traditional way of doing a long division calculation. So it's not like I'm saying don't show them how to do long division. Of course, you show it to the children and you let them experience it, but just I wouldn't place as much emphasis on it as maybe as I would have when I first started teaching. And when I'm using this method of teaching a new topic, the emphasis is definitely on sense making and them drawing on their previous experiences, and accuracy and getting every answer right isn't really the most important thing. It's more about how they do it rather than what answer they got. So this is an example of how we started off the unit, and it was our focus was like introducing them to division with large numbers for the first time. The problem was that a punnet holds 24 strawberries. How many punnets can be filled from a basket holding 120 strawberries? And the emphasis was, can you solve this problem in more than one way? So we have an example of a child's work here where they filled a full page just focusing on this problem. You can see that they found two different ways of doing it initially by themselves when they were working with their partner. So the first way they did it was split the 24 into 20 and 4s and see how many 20s and how many 4s would take to use all the 120 strawberries. And then they used repeated addition, where they did 24 plus 24 is 48, then add on another 48, and then another 24, so 5 punnets altogether, used up all the 120 strawberries. So they would have worked with a partner for about 10-15 minutes on that, and then we had a whole class discussion where the children shared the different ways that they solved the problem, and I recorded them up on the whiteboard. And beside each child's method, I'd write their name and maybe the word way. So I might say Mary's way of solving it, or Patrick's way, to give them ownership of the methods that they suggested for the class. Asking questions as well, like, did anybody else solve the problem the same way as Mary? Brings in that one person might be sharing it with the class, but that more than one person came up with it. Then after that, they were asked to still work on the same problem with the same numbers, but to try out some of the ways that they saw on the board. So you can see that this child tried out 3 different ways, after it was put up on the board. So they tried out another addition method, a subtraction method, and a method that one child came up with in the very first lesson, where they looked at the numbers, they made an estimate, and then they would multiply to see how close they could get, or to see could they figure out the answer using multiplication, something they were very comfortable using. You can see that the difference, I guess, to maybe a traditional page of questions is that instead of having lots and lots of different questions answered, they have one question answered, but in lots of different ways. So they're kind of thinking around the idea of division rather than just copying a method over and over again. We had a series of problems like that for the first week, where we really focused on the children coming up with their own methods. The next one that we had was this problem where a car transporter delivers 216 cars over 18 trips. How many cars were carried on each trip? So here the numbers are changing. You can see on the side there that using repeated addition takes ages. They have to add 18 together loads of times to get to the 216. But on that piece of work, you can also see where that child did it the long way and then realized, if I double the 18 and do 2 trips in each of my calculations, if I add 36 each time, it's going to reduce the amount of work required by half. And different children were working in different ways. It's great. Teaching in this way is brilliant for differentiation, because in one lesson you might have a child using repeated addition or repeated subtraction, and you have another child who realizes that 6 3s are 18, so they can divide 216 by 6 and then by 3. It's a great example of low entry, high ceiling, because every child's input is valued at the end. So all the way through, if there's children using addition and subtraction, their method still counts as another way of solving this problem, and they feel like they've succeeded at the end of the lesson. So it's really about how they approach the topic rather than the answer that they get. As this was part of a research project, at the end of each lesson, we asked the children to reflect on their learning. And some of the responses were really interesting to read. For example, the one in the dark blue there, you had a child saying that I will use the long division way and the subtraction way. They are easy and fun. And another child saying, tomorrow I will use the long division way because it is interesting. So after the children were really comfortable solving these problems, that they could come up with a solution their way if they wanted to, then I showed them the long division method, and they were encouraged to try it out if they wanted, or yeah, they were all encouraged to try it out, but they had the flexibility to go back to their way if they found it easier. But you can see that you have children saying for themselves that they find this interesting and they want to learn more about it. In the light blue, you have another child saying, today I did division using subtraction. I used James's way. It gives you the remainder, if there is any. Tomorrow I will double the divisor to make it quicker. And divisor was a word we gave them because they were looking for a name to put on the number you're dividing by. But here you really see that they're evaluating what they did, and they're looking at what the other children are doing and seeing if there's a better way to do things. So instead of all of the ideas coming from the teacher or coming from the textbook, the ideas come from the children themselves. And it's an interesting exercise to ask the children from time to time. You know, what did you learn today? How did you solve today's problem? And what would you do differently next time? It's an interesting question to ask. So I'd say if this is something that you're interested in, or that you think you haven't really done before, but you'd like to know a bit more about, and you'd like to maybe try it out in your own classroom, I'd really encourage you to give it a go. This unit of work in more detail for the division with 5th class is up on mathsforall.ie. There's there's presentations there. All the problems are ready just to display in the classroom, and there's examples of children children's work where they solved these questions. So it's all there for you. If you're not teaching 5th class, you can use your textbook to help you teach in this way. So all of those numbers are similar to the questions that are asked in textbooks. It's just maybe not doing all of them, or picking one to focus on from each part of the chapter and trying to explore it in a deeper way. And I'd really encourage you to skip pages of your textbooks, because if you can't do everything, there's a limited number of time in each day. So if you're doing something where the children are deeply looking at one question and working around it, that's extremely valuable work. And just, you don't have to get every page of the book covered as well. The final part then that I'd like to look at is how mathematical modeling is connected with my problem-solving journal and the opportunities that we try to create within my problem-solving journal for modeling. The type of modeling that I was speaking about with the division is somewhat different to my problem-solving journal because it spanned 2 whole weeks. Whereas my problem-solving journal provides 30 lessons that, they're standalone lessons, usually one lesson per problem, and some of the other modeling activities would take longer. So they're probably more connected to the likes of the STEM investigations, but we also were very conscious to try and include models within the book that children could use to help them make sense of some of the trickier maths concepts that they'd encounter. So the program consists of 6 books. As I mentioned at the start, I was a series editor on the entire program and author of 5th and 6th class. And accompanying each book, there are teacher notes available on Folens online, and these teacher notes really try to set it up to make using the book as easy as possible. One of the very important aspects of it is the anticipated student responses. So to accompany each problem, we've tried to think about the different ways that children might approach a problem, and to include examples of how different children might work on a problem, to make it as easy for teachers using the book to go in and use these problems with their children, so that they feel prepared to work with the children and to deal with the different responses that would come up to a problem. Just going to show you a couple of samples now of some of the models that are in my problem-solving journal and some of the opportunities that children have to model mathematical ideas. So here, these are all from the 6th class book, taken from my class this year. So here you have an example of a fractions problem. And when I was writing this, fractions in 6th class can be quite complicated. So some of the ideas are very abstract. So with the fractions, decimals and percentages, we were really conscious to include models that would help the children make sense of complex ideas. So this is an example of where grids were used and shading was encouraged to help the children make sense of the complex idea, but to do it in a way that was visually engaging and to help them make more sense of it. Earlier I mentioned this problem with the tomato cans, where the children have the dimensions of a box and they have the dimensions of a tomato can, and they have to try and make a model of the situation and try and figure out how many cans could fit in the box. What I love about this is kind of how almost messy the child's response was, because they were really getting into drawing their diagrams out, and you can just, when you look at this, it doesn't look perfect, but you can see the thinking the child was doing as they were figuring out different orientations, trying to see how they'd fit the cans, and then the number work going on in the background as well as they're multiplying and using the operations to help them as well. So it's a great example of a child trying to record and make sense of this issue with a model that makes sense to them. Here you have another a similar example to the same problem, where a different child, where they were working with their visuals and also incorporating the number work round about it. We have another problem on listening speeds, and this problem basically focuses on how long would it take to listen to 3 minutes, a chapter that is normally 3 minutes long, if you sped it up. And in the workspace that the child has used here, you can see that they were using double number lines to try and figure out how long it would take them to listen to the chapter at 1.5 speed. So I'm just going to zoom in to try and show you that. So you can see here that they said that a 1 minute in real time would at 1.5 would be, yeah, that in 2 minutes in real time they'd have listened to 3 minutes of the book if it was sped up. So great use of number lines to model here what's happening in the context of the problem. If I was doing that problem myself, I'd probably jump in using number and using the operations to figure it out. But when a context was presented, what made sense to this child was to draw out number lines and to use those to figure out a solution to the context in the problem. We also at times introduced new models within the book. So this is an example of line multiplication. So the question 24 multiplied by 13 is something that you'd expect 6th class children to be really familiar with. But we introduced a different type of multiplication to try and let them look at an operation they're familiar with in an unfamiliar way, and to try and make connections to what they'd be familiar with doing, and just to, I guess, show the creativity that exists in maths and the different ways that we have of solving problems. So they're just a snapshot from the 6th class book of how modelling is incorporated, and the different ways that children can engage with the problems in the book. I'm using it with my class this year, but when I pick up the books and look at them at the end of a lesson, I never expect them to look identical, unless the children were working together, maybe. But it's what's lovely about it is different children will think about it in different ways and approach a problem in different ways, and that's really one of the main aims of the book, that children are encouraged to model their thinking and make sense of the problems in their own way. Just some points of reference here if you found the ideas interesting. On the ncca.ie, there's a huge source of information. As I mentioned, there are draft support materials on mathematical modelling. They were written in conjunction with Dr. Nick Furry, and they are really, really teacher friendly. Great examples in there. If you're looking for information on it, they're really good. Their support materials 9, 10, and 11, and the draft curriculum is also up there. On mathsforall.ie, there's activity plans, and the unit of division is there. Maths for All are also running, I think, 3 webinars between now and the end of the year in conjunction with Clare Education Centre, with experts in the area of maths education. I've signed up for the 3. I'm sure they'll be really informative. And if you'd like to know more about my problem solving journal, the information is all on folans.ie. So if you have any question, I'll pass back to Elizabeth. And thanks a million for listening. And I hope everyone enjoys the Easter holidays. And if you have any questions, feel free to pop them into the chat box.
Thanks a million, Patrick. That was really interesting. It just shows how creative children can be in a maths lesson, which is fantastic. If you can bear with me, everybody, I just have 3 quick slides to go through. But in the meantime, if you do have any questions for Patrick, you can pop them into the chat icon up the top of your screen. As Patrick said, we have all the pupil books and some sample teaching notes for you to try on folens.ie. So they're there now and will be there after Easter. So perhaps you could tackle a problem when you come back after the Easter break with your class. And just to say, as you all know, it is a year of great change with the new school book grant scheme. Just a reminder that your local Folens rep is available for calls and consultations at a time that suits you. They've lots of information on all our programs and can help pinpoint how the content within those programs can meet your classroom needs. They can also work with you and your school to find the best value to meet your school requirements. And they will have lots of information on great special offers that we will have as well. And those offers are across our portfolio, including our literacy resources. And then finally, we have another webinar to help prepare you for the new curriculum. That webinar will take place on Tuesday, the 25th of April, and the topic that will be focused on is problem solving in junior classrooms with teacher and author Elaine Dillon. So you can register for that webinar now on folens.ie. And keep an eye out on email and on social media for other events that we will be supporting after the Easter break. So now I will ask Patrick and Ciara to join me once again to answer any of your questions. So I think there was just a question there, Patrick. Are we supposed to be implementing the new draft maths curriculum at the moment, or are we supposed to wait for the department to officially train? Do you know?
Yeah, so the draft curriculum is still only in draft form, so it's not for implementation right now. But I would say if anyone wants to try out these ideas, they aren't unique, shall we say, to the draft curriculum. That these are the ideas that we've been hearing in the teacher education colleges for years, and a lot of the ideas are there in our existing curriculum. So it's kind of, I'd consider this curriculum kind of a refocus, that we're trying to really get to the bottom of what is good teaching from the curriculum that's out there, and to put it into practice.
Great. And just another question there. Does the My Problem Solving Journal work alongside the core books, or like how would you use it with the existing maths books you're using in the classroom? Patrick, do you want to take that, or Ciara?
Yeah. So the problem has, or the book has 30 problems in it, and each one is mapped to a topic that you would traditionally be teaching. So if you look at the contents of this book and the contents of Planet Maths, you'll see that there's alignment there, the idea being that you'd have one a week to use at some point during your teaching of the topic. And there are mapping documents mapping My Problem Solving Journal to the core books that are out there, so that you know that document's there for you to stick into your long-term plans, so that you know if you're teaching this topic, you need to go to this page and teach this problem this week.
Great. And Ciara, you might know this one. Any idea when the new maths curriculum will be put in place in schools? Yeah.
Yeah, so I mean, what we have heard is that there is a plan for it to be released soon, and that there might be a familiarization period next year. But I can't say that for sure. We have to wait for the Department of Education to confirm that. So we're all a bit up in the air, because I'm sure everyone feels about it at the moment. But what we have been reassured of is that from next year, it'll be familiarization. It won't be a big bang that you have to change everything you're doing. So I'm sure we'll see it soon. There's a lot going on in education at the moment, as everyone's aware, between the free school books, the primary curriculum framework, which is on the way. So in the midst of all that, I'm sure we'll get an announcement about new curriculum in the coming months.
And I suppose they'll go hand in hand, Ciara, that when will all the maths books be updated to reflect the new curriculum?
Yeah, well, we're certainly planning on releasing some new books and resources to support the new curriculum. We will be looking at starting to release that for September 2024. So without the curriculum confirmed at the moment, it's very hard to have anything out. Obviously we don't want to do anything that wouldn't align with the curriculum, but we will be working on new materials for release to schools from September 2024.
Brilliant. Thank you. Yeah, I think that's all the questions that we have. Yeah. If anyone does think of any questions, by all means, contact your rep, and they'll hopefully be able to answer, or you could come through to Folan's ourselves. And also we'll have, as I said, that additional webinar on the 25th of April. But thanks a million, everybody, for joining us on your last few days in the classroom before the Easter break. So I hope you all enjoy your Easter, well-deserved holidays, and enjoy the rest of your evening. Thank you very much. Thank you, Pat.